Next, I want to focus on locating absolute extrema. So remember that if f is a continuous function over a closed bounded interval, then the absolute maximum of f over I and the absolute minimum of f over I must occur at the endpoints of I or at a critical point of f in I. So that would be absolute extrema. So we need to evaluate in f at the endpoints x equals a and x equals b. We need to find all critical points of f that lie in that interval, and then we need to compare the values found in part 1 and 2, and then the absolute extrema must occur at the endpoints or critical points. So the largest of these values will be the local max, and the smallest will be the local min. So the first thing I want to do is find the value of f of x at the endpoints. So f of 1 equals negative 1 squared plus 3 minus 2 that's going to give me 0. Next I have f of 3. That's going to give me negative 2. Okay, so those are our values. We evaluated the endpoints. Awesome. Step 2, find the critical points. First thing I got to do, take the derivative of my function. So the derivative of quadratics is going to become a linear function. So I have equals negative 2x plus 3. Next I need to set this equal to 0. But this whole thing is defined over R, right? So there's no undefined critical points. That's good to know. So we set it equal to 0. That's going to give me x equals 3 halves. So since 3 halves is in our interval from between 1 and 3, I need to check it. So if I have f of 3 halves, and I substitute that into my original function, that's going to give me that's going to give me 1/4. Okay, so f of 3 is negative 2, and f of 3 halves is 1/4. So what does that tell us? So the largest of these values, I have the values of 0, negative 2, and 1/4, is going to be the absolute maximum. So this would be 1/4. This is our absolute max. And that the smallest of these values will be our absolute minimum. So f of 3 right here, this is our absolute minimum. Let's try another example. So I have f of x equals negative 3x to the 2/3 over 0, 2. So I need to evaluate this at the 2 endpoints. So if I take, this is step 1, if I take f of 0, that's going to give me 0. And if I have f of 2, that's going to give me 4 minus 3 times 2 to the 2/3. This is right about negative 0.762 if you plug that into your calculator. It's important for us to note that I need to go ahead and take our derivative for step 2. F prime of x equals 2x minus 2x to the negative 1/3. It's important for us to note, if we look at the derivative, that our derivative isn't defined when x doesn't equal 0. Okay, if I plugged in 0, I would get undefined. So I need to set my derivative equal to 0. So I have 2x minus 2x to the negative 1/3 equal to 0. Oh, but I had factored out a factor of x. take a step back real quick here. I set this equal to 0, and I factor out a factor of x. So I have x times 2 minus 2 x to the negative x to the 4/3 equals 0. Now x equals 0 is not defined, so we can ignore this for my function. So I have 2 minus 2x to the 4/3 equals 0. Subtract 2 from both sides. Negative 2x to the 4/3 equals negative 2. X to the 4/3 equals 1. So x equals plus or minus 1. So our critical points are when x equals 0. That's what we just found. We found the critical point. So that's when x equals 0, plus 1, or minus 1. So now I need to substitute in my function. I know f of 0. I know f of 2. Negative 1 is not in our interval, so I can ignore that. So I just need to find f of 0, which we actually already found. So now I just need to look at f of positive 1. So f of 1 equals, if I substitute that in, I'm going to get negative 2. What does that tell me? Okay, that tells me, if I look at the 3 points I have, that f of 1 equals negative 2 is my absolute minimum. And 0 is my biggest number of the 3. So this is my absolute maximum. Last example. Okay, so the first thing we do are find the endpoints for f of 1 and f of 4. So f of 1 equals negative 3. F of 4 would equal 16. Next, I need to take the derivative. I find f of x equals 2x minus 4. I set that equal to 0. I get that x equals 2. 2 is in my interval, so I find f of 2. That's going to be 2 squared minus 8 plus 3. So f of 2 equals 4 minus 8 plus 3. 4 minus 8 is negative 4 plus 3 is a negative 1. So let's double check f of 4 is 16. This is not quite right. F of 4 is going to be 16 minus 16 plus 0 plus 3, which equals 3. Sorry about that calculation error, guys. So let's take a look. I have f of 1. We'll check this too. 1 squared minus 4 is negative 3 plus 3 is 0. Okay, well, we were having some issues. So let's go ahead and look at our interval right here. So here I have negative 1. That's the lowest value I got. So this is my absolute minimum. And here 3 is our biggest value, so that's my absolute max. There we found the local extrema. Hooray!